Hello everyone. Today we are going to understand a very interesting and practical project, Instagram database schema using a SQL. In this session, I will explain everything step by step, just like a teacher in a classroom. So even if you are beginner, you will be able to understand how a real world application like Instagram is designed at database level. What is this project? First, I will create database, the name Instagram in the postgre, in the postgre. This is the name of Instagram database. I would create in this postgre. After that, we will be created, and then I convert in Google Word so that I will upload project on alma better platform. What is the project? What does project actually do? This is project about designing a database that store all the important feature of Instagram, such as user, post, comment, likes, follower, hashtag. So basically, whatever you see and use on Instagram, we are trying to represent that using table in SQL. Basic concept. Before we go into the table, let's understand on basic idea. Database is used to store data in an organized way. Now think about this. User can create many posts. One user post can have many comments. One user can follow many users. So we cannot store everything in one table. That is why we divide data into multiple tables, and connect them using relationship. Let's start with user table. Let's start, let's start with user tables. This table stored all the information about user. It has following column: user ID, username, and full name, email, biography, and registration date. Now, very important point, user ID is primary key. What does that mean? It means each user will have unique ID and no two user can have the same user ID. So this table became the foundation of our database. Post table. Now let's move to the post table. Post table, any photo or video uploaded by a user is called post. This table includes post ID, user ID, caption, and image URL, location, and post date. Now, here is the key concept. User ID in the table is a foreign key. What does that mean? What does that mean? This column connect each post to the user who created it. A relationship. Let's understand the relationship here. One user can create many posts, but one post belongs to only one user. This type of relationship is called one-to-many relationship. Comment table. Now we will proceed comment table. This is a comment table. Now let's understand the comment table. When a user write something on a post, this table has comment ID, post ID, user ID, and text comment data. Now think carefully. One user can comment one many post. One many post. One post can receive many comment. So what type of relationship is this? This is a many to many relationship because multiple users interact with multiple posts. So Next is the like table. Next is likes table. What is a like? When a user show interest in a post, column include like ID, post ID, user ID, and like ID, and like date. Again, observe one user can like many posts. One post can be liked by many users. So again, this is a many to many relationship. Followers table. Followers table. Now let's understand the followers table, which is very important on Instagram. On Instagram, you can follow other user can follow you. This table include follow user ID, follower user ID, follow that. Now understand this carefully. Both IDs refer to the same user table. That means user are connected to other users. Special concept. This is called a self-referencing, referencing many to many relationship, because user is related to another user within the same table. And now hashtag and post hashtag table. Now let's understand hashtag. Example, travel, food, fitness. Hashtag travel, hashtag food, hashtag fitness. It all the hashtag. Problem, one post can have multiple hashtags. One hashtag can be used in multiple posts. So how do we solve this? We create a junction table is called post hashtag. This table connect post ID, hashtag ID. This help us manage a many-to-many relations. Why this design? Now you might ask, why do we design to database like this? Is answer to avoid duplicate data, to keep the structure clean and organized, to improve performance, to represent real world system correctly. Key learning. From this project, we learn how to design relationship database. What are primary and foreign key? How relationship work, how real applications store data. So to conclude, this project show how real world application like Instagram can be built using SQL database design. It include proper table structure, strong relationship, scalable design. Let's see, users can be multiple posts. So then it will give one to many relationship. And one user can multiple comments. Can be multiple comment. So that multiple user comment multiple comment. So many to many relations. Multiple user can be can do multiple likes on multiple users. So it will give many to many relationship. Multiple user can follow multiple user, many to many relations. Post multiple post on multiple post on multiple hashtags. Multiple hashtags on multiple post. So it will give many to many relationship. I hope you now clearly understand how Instagram work behind scene at database level. ER diagram. Conclusion, in this ER diagram, the user entity represent Instagram user. Each user can create multiple posts which form a one-to-many relationship between user and post. User can also comment on post and like post. The follower entity represent the man-to-man relationship where user can follow other user. Additionally, post can contain multiple hashtags and each hashtag can belong to multiple posts, which is handled through the post hashtag junction table. They all are it. This is conclusion about database of Instagram. Now we will proceed ER diagram. ER diagram, it means entity relationship diagram for an Instagram database. I I created by using a platform diagram IO. Then it will upload on Google Word so that we easily upload on platform on alma better. Now, before we go deeper into the table, let's understand the ER diagram of this project. First, what is ER diagram? An ER diagram stands for entity relationship diagram. It is a visual representation of the database structure. In simple word, it shows what table we have, how those tables are connected, and what type of relationship exists between them. Now, let me explain how I create this ER diagram. I used diagram.io. I used platform draw.io, also known as diagram.net, to design this diagram. This tool is a free to use, easy for beginners, widely used for database and system design. Using this platform, I create entity, attribute, and relationship in a structure form. What does this ER diagram represent? How? Let's understand what this diagram actually represent. Each box in the diagram a table. It called entity. For example, users, post, comment, likes, comment, comment, like, follower, and hashtag and post hashtag. Inside each box, we have attributes, mean that columns, and the line connecting the box representing relationship. Understanding relationship from your diagram. Now let's read the relationship step by step. User, post, connected by line. One user can create a multiple post. This is a one-to-many relationship. And user also connected to commented by line. So post can have multiple comment from multiple users. This become a many-to-many relationship. And user like. One user can like many posts. One post can be liked by many users. Again, a many-to-many relationship. User followers. User followers. This is a very interesting. User can follow other user. So this is user-use relationship, which is a self-referencing many-to-many relationship. Post hashtag. One post can have multiple hashtag. On hashtag can belong to multiple posts. This is a handle using junction table. Why ER diagram is important? Now the question is, why do we create a ER diagram? Answer. It helps us plan the database before coding. It gives clear structure. It avoids confusion. It ensures correct relationship. In real world project, ER diagrams are always created before writing SQL query. Simple summary. So in simple term, ER diagram is blueprint. ER diagram is nothing but it is a blueprint of the database. Just like a building need a map before construction, a database need an ER diagram before implementation. Thank you. I hope you understand my language. Thank you.